Hi guys, in this specific discussion I'm going to look at a summary of the description of an atom, and of course in understanding the concept of an atom it's going to give us an insight into various chemical reactions that we're going to see in chemistry, and some of the laws that are being applicable in various areas of physics and some of the application areas. In a sense, we're going to see that for the definition of an atom, this basically is the smallest unit of matter that that cannot be divided by chemical means, and which forms of a building block of matter in an essence. So this basically then therefore can give us a foundation for defining the concept of a matter, whereby we say that the matter consists of atoms which are made up of the subatomic particles of protons, neutrons, and electrons, which are fundamental particles. Of course, as we advance, we're going to see various aspects which have been used to describe this subatomic particle, and some of the phenomena that have been observed over time, which are going to give us an insight into various other evidence which can pinpoint or, of course, illustrate some of the presence of some of the other subatomic particles that we're going to encounter in our discussion. So for today, we're going to see that these atoms of an element are going to form what we call an element, whereby an element is going to consist of entirely the same number of course, the same type of atoms in terms of characteristic. So in a sense, we're going to see that there's a slight variation due to the presence of some of the atoms which are having a different or a variation in mass, in numbers, especially when we talk about the concept of isotopes. Now, in my illustration, I've given the right side of the board a variation of this specific case for the uranium, whereby we're going to see that uranium as an element as an isotope which consists of this specific nuclide, which is consisting of an atomic weight of 235 and 238. So basically this specific atomic number is going to be the same, but there's going to be a variation in the atomic weight, which is going to be shown as this. And this is going to result into a variation in the numbers of what we refer to as the neutrons, which are the nucleons or contained in the nucleus. And therefore, this is going to have a specific characteristic that we're going to understand, especially under the topic of radioactivity, insofar as stability of atoms are concerned. So in this particular case, therefore, this is the fundamental building block of matter that consists of these subatomic particles. And we said that an element is going to entirely consist of atoms which are going to be similar, especially in mass, and perhaps some of the aspects that we're going to see. But there are some unique cases of isotopes that I've mentioned. Now, earlier on in one of our videos, I discussed on the concept of representation of an element. Now, I'm going to presume that we understand this concept of atomic weight and atomic numbers being given and the chemical symbol as such. Now, for these subatomic particles that I've stated, they consist of various characteristics in terms of charge and perhaps mass, whereby we are going to see an electron consisting of a specific constant for the charge being given in coulombs and a proton. So these are almost the same and they're opposite charges. So we're going to expect that the behavior of an atom, or rather the protons and the electrons, are going to experience their attractive forces, which are going to cause this sense of stability in an atom, or the atomic structure that we defined, and therefore they are going to keep the electrons and the protons in place. So in this case, of course, I've talked about the concept of atomic number and the mass numbers. The atomic number is the number of protons plus the neutrons that are contained in an element. And the atomic number, of course, this represents the number of protons in an element. So there's a slight variation in terms of the weight of these specific subatomic particles, whereby we're going to see that one atomic mass unit is of a range of this specific magnitude to negative 27. And then, therefore, if we compare the mass of an electron or a proton or a neutron, then therefore we're going to see that the proton and the neutron are going to have a mass of one atomic mass unit, whereby for an electron there's going to be a difference of around this particular figure for a fraction of 1 over 1840 as compared to one atomic mass unit. So therefore that's going to give an electron a characteristic of having a relatively less weight as compared to the neutrons and the protons respectively. So these are some of the aspects that we can use to describe an atom. And I talked about the concept of an isotope that is consisting of various numbers of A, but they are different number, the same number of Z, but A that we're going to see later. But this is not going to affect their chemical properties, but their physical properties are going to be different. And this is just an illustrative way in which we can be able to represent this specific aspect of matter that we have called an atom. So catch us in our other videos that we're going to see on the concepts of atomic structure. And I'm going to put a link in the description box for these specific videos so that they can assist us understand further into this aspect of our atom from its time of discovery to the present understanding. So that is it now for now, guys. Bye, God bless.